Blood pressure. Let's talk about what we mean by blood pressure. We saw already that when the heart pumps, the ventricles contract. They create pressure in the bloodstream, which pushes the blood through all the blood vessels. What I want to just do is a quick picture of sort of a reminder picture. We had, the branching arteries, which branch off continuously smaller and smaller until they become arterioles, and then they branch into these tiny little capillaries, right? And the capillaries, they're just a straight tube. But I draw them in different colors because we're trying to show that the blood sort of changes in its composition. The oxygen is being taken out, right? So the capillary networks look something like this. And then they go into sort of larger veins. Not really sure if I can draw this very well, but you get the idea. The venules, and then of course a larger vein, and off we go. So the thing is that the red side is the side that the ventricle is pushing against, especially the left ventricle. And because it's pumping hard and it's pushing blood, when we have this picture, what we end up with is a fair amount of high pressure here. And we said that arteries carry blood under high pressure. So what happens to that pressure? Well, think about a hose. If you have the water of the hose and it comes firing out the hose, right? If you have a tiny little, if you have a small hole in the end of the hose, then the water comes out and it shoots quite a distance because of the pressure. But if you take that and you attach it to a sprinkler, the sprinkler has like many, many little holes. So all of the pressure has to be sort of divided up among all the tiny holes. So when it comes out of the sprinkler, the pressure is less than when it's coming out of the actual hose. And that's because you're using many, many small holes. Same as your shower. If you think about your shower head at home. Anybody have one of those rain shower heads? You ever seen those? They're like a big round thing and the water comes down. Well, the pressure is not super high. And that's because there's many little holes. So all the pressure is being distributed over the many holes. So what happens here, when the blood enters into the arterioles and then into the capillaries, it's like a sprinkler. It's being sort of distributed over the many, many little tiny blood vessels. So the pressure drops as it goes through the capillary network significantly. And then on the other side, we have basically low pressure in the veins. So because the capillary network is made up of many, many little blood vessels, the pressure ends up dropping every time it goes through. So anytime you have a capillary network, which is anytime the blood is interacting with tissues of the body, then you're going to have a drop in the pressure because of the network itself. So that means that our arteries are under high pressure, and that's why the arteries have a much thicker muscular wall, right? So they can handle that pressure, whereas the veins don't need as much muscle in their walls. It's a thinner wall because the pressure is quite low. So if you push your fingers against a vein, you don't really feel much happening, but you can find a few arteries, like in your wrist, right by your thumb, the base of your thumb. You can find, I think it's called the brachial artery, and you can feel your pulse, right? And the pulse is essentially every time the heart beats, it's pushing the blood, and it's creating that high pressure that we feel. You can also find your pulse in your neck, right around here, where your carotid arteries are. You can find your pulse in your femoral artery, which kind of goes sort of down through your groin. There's different ways of finding a pulse, right? Everybody's been able to find their own pulse, right? You can do that. And of course, it's not a constant pressure because the heart is pumping like every so often. So the pressure goes up and drops and goes up and drops. And so what we have to do is we have to distinguish the blood pressure that we're talking about. So blood pressure is measured at its peak or highest value, and that of course is the moment the moment the ventricle contracts. And we're going to talk about the left ventricle primarily because the right ventricle is only pumping through the lungs, and the right ventricle is a little bit smaller and weaker, doesn't pump as hard. So the pressure in the pulmonary arteries is going to be slightly different, but that's kind of not really critical to everything else that's happening in the body. So the moment the ventricle contracts, produces the highest amount of pressure, and we call that the systolic pressure. Systolic pressure. So that's the most pressure that your arteries are going to feel. Boom, at that exact moment. That's when you feel your pulse. In between, when the heart is not pumping, it's relaxed for a moment, then we have the lowest possible pressure, right? It's measured at its peak, and so I guess measured at, and then its peak and at, these are kind of like extras, and at its lowest, which is between ventricular, which is the ventricles, ventricular contractions. And that's called the diastolic pressure. So we describe the stages of the heart. When the heart is contracting, that's called systole. And when it's relaxing, it's called diastole. And so we have systolic pressure when it's contracting and diastolic pressure when the heart is not contracting, in between. And of course, we can measure this. We can measure this in different kinds of units. Traditionally, though, we measure pressure in something called millimeters of mercury. And that's because in the old days, we used to build barometers out of mercury to measure air pressure. And so that was one of the first things we used to measure. And so the unit became how many millimeters can you make a column of mercury rise up and down in a tube by putting pressure on. You know what I mean? And so that's the unit, but that doesn't really matter too much. They used to define standard blood pressure. So when they define a standard, essentially what they do is they take a whole bunch of people, measure all their blood pressures, and see what the average sort of is, right? In average healthy people. So the standard was measured like this: the systolic compared to the diastolic. And it would give you a ratio, and 120 over 80 was sort of considered to be the golden standard of blood pressure. As time goes on, nowadays, we don't really use this particular number anymore. We understand that blood pressure, of course, is quite variable. Your blood pressure will rise and fall depending on what you're doing, depending on whether you're excited or not. If you see a bear that's chasing you, your body will send out the adrenal glands, will send out the adrenaline, will pump you up, and your heart will beat faster, and the vessels will constrict, and the pressure will go up. Because for a short time, higher blood pressure means better movement of oxygen through your system. So that's good because you're going to run from a bear. But so this can go up. When you exercise, your heart rate goes shooting up, and it can also mean that your blood pressure will change. So blood pressure varies throughout the day. So when you measure blood pressure, you need another standard. You can't just say, let's measure this person after they've ran 10 miles, this person after they've sat on the couch all day. So they have to basically measure it. It's measured as a resting blood pressure. So this is a resting blood pressure. When you go to the doctor, you have to sort of sit quiet, rest a little bit, and they measure your blood pressure, and that's how they get the number. But as I said, they don't really look at 120 over 80 anymore. Now they sort of understand that there's a range, right? So there's actually a range of healthy blood pressures, and it depends on the person. And so the range could be, anywhere from, if you get down around 110, doctors might go on the top. Doctors might start to wonder, that's a bit low. And if you get up over 130, doctors might start to say, that's a little bit high. And on the bottom, it's the same thing. If you drop too much below 70, the doctors might wonder. And if you get up much over 90, doctors would begin to wonder. So now, when you take your blood pressure, doctors usually are looking at all these factors and trying to make sure. And of course, they want to make sure that, they take your blood pressure several times to get a good sort of indication. And because your blood pressure is constantly changing, right? And what's interesting is blood pressure is never taken as an average. You don't take your blood pressure 10 times and average it. You take your blood pressure 10 times and you look for the highest and lowest numbers as the warning signs, right? So if you were to measure your blood pressure and it fell in this particular range, doctors would probably say no problem. And there's another weird thing that happens with people who go to the doctor. Sometimes they get a little bit nervous. And of course, if you're nervous, you could be at home. In fact, this happens to me quite often. I don't know why. It's a weird thing. When I go home, I measure my blood pressure, and I've done this many, many times. And my blood pressure will be, 120 over about 75 or something, like within the normal range. And then I go to the doctor, and they measure it, and it's 136 over 80 or 82, right? So whenever I go to the doctor, my blood pressure is higher than when I'm sitting at home relaxed. And the reason for that is because going to the doctor can sometimes make us nervous. And if we get nervous, our body responds, right? The adrenaline begins to pump, the arteries begin to constrict a little bit, and the heart might beat slightly faster, and it changes your blood pressure because being nervous is what happens when you're trying to fight a bear. And so for some people, doctors realize that when you go visit them once and they take it one time, it could be higher than normal. So if a doctor sees that your blood pressure is high, they might say, here, I want you to go home and I want you to measure your blood pressure over the next 3 weeks and record it and bring it back so they get a better idea. This is actually called white coat syndrome. White coat meaning you're the doctor, and the idea is that whenever you go to a doctor, you see someone in a white coat, you get nervous because they're going to give you bad news, right? Doctors are, what's wrong with me? And there's this kind of nervousness that happens, and it's quite common. Okay? So obviously your blood pressure will be changing over the course of a day anyway. When you get up in the morning versus at night, whether you've been moving, whether you're not. And of course, guess what? What we've discovered, every time we talk about, how do you maintain a healthy blood pressure? Well, the real answer is exercise. Our bodies are designed to move far more than we move them, right? Our bodies are designed to wake up in the morning at 7 o'clock sunrise. Don't eat breakfast because there's no breakfast. You're a caveman. You get out of the cave, you bring your club and your spear, you and your buddies, you go tracking some kind of wildebeest, and you do it for like 4 or 5 or 6 hours. So around 3 in the afternoon, you finally find one, you wrestle it to the ground, you beat it with clubs and attack it, and then you have to carve it all up, and then you have a little bit to eat. So our bodies are designed for pretty vigorous living, because that's how we live for millions of years. Nowadays, our living is far less vigorous. So the key thing, or the key problem we have, is not enough exercise and movement and so on. And of course, your diet can play a role as well. One of the things they used to say is that a diet high in salt, if you eat too much salt, it'll cause high blood pressure. We're starting to rethink this because we're not convinced that this is the case. Here was the theory or the idea. The idea was if you put a lot of salt into your stomach, there's salt in your stomach, right? That salt will travel through your intestines and it will be absorbed into those capillary networks around your intestines. In other words, the salt goes into your blood. If the salt goes into your blood, then think about it. Let's say this is your blood with lots of salt in it. The tissues around the blood in the intestines will be less salty because the salt has moved inside the blood. And that means that water, by osmosis, will try to cross the membrane to water it down. And so water will be drawn into the blood to sort of follow the salt to even out the concentration difference. And if you add water to your blood, you increase its volume, which increases its pressure. So that was the idea that they were worried about. Studies are sort of showing now, though, that it's not quite that simple. And so it's not necessarily true that a high salt diet is going to cause high blood pressure, but it still sounds like it might be linked in some way. So obviously, the old rule of biology, right? Too much of anything is bad. And so reducing salt is still a good idea for all kinds of reasons, but it might not be just simple as if you eat a lot of salt, you're going to get high blood pressure. And that's true for almost everything in medicine. You know, these little things that we discover, there's always sort of exceptions to the rule, and they're not quite as simple as we think. Okay, so your healthy diet and healthy exercise maintains a good blood pressure. And that's really all there is to say about it. Some people have lower blood pressure than others because they exercise a lot. If you're a marathon runner, your blood pressure might actually be lower, your resting blood pressure. Marathon runners might have very powerful ventricular contractions because their heart might only beat 55 times a minute, whereas your heart beats about 75 times a minute. So the more athletic you are, the less your heart has to beat, right? Because it's stronger. So they might have blood pressures of, 120 over maybe 70 or something, 65 or 70, the lowest end. And that's because when their heart rests, everything relaxes. The other thing that affects blood pressure, of course, is if you have a blood vessel, we also know that what can sometimes happen is if you have too much fat and cholesterol moving through your bloodstream, it can collect on the sides of the walls. And what happens is it's kind of like the cells here react to it, and they grow like a scabby kind of plaque. And this scabby kind of plaque can build up if you don't get rid of it. And it builds up, and it makes for narrowing arteries. And that means that the pressure is now much higher inside there. And so if the higher pressure could be a sign that you're suffering from atherosclerosis, right? This thickening of the walls of the arteries. The way to prevent this, of course, is, again, a healthy diet with balanced fat intake, not no fat, but balanced fat, and of course, exercise. That's, again, those are the two things. What we're discovering is like 90% of what's wrong with people today eventually comes back to not enough exercise. It's really interesting. Stress responses are the reason behind a lot of our illnesses. So this is what happens when you get hardening of the arteries. This can start happening when you're like your age, but it might take 15 or 20 years to build up to the point where the arteries get too narrow. The other problem, of course, is the blood cells themselves might get caught and stuck here. And if they do, they create a blockage, which causes the artery to swell up because of the pressure. Just like if you grab a hose and squeeze it, it makes a little bubble if it's not very strong, right? And this swelling up is a very dangerous thing because if it swells up too much, it could burst. And that's called an aneurysm. If you've ever heard about someone who's had an aneurysm, it's a burst blood vessel because of a blockage, which could very likely be the result of hardening of the arteries as well. If this aneurysm happens in your brain, then we call it a stroke. So a stroke is what it's called if it happens in your brain, but it's the same idea. And of course, if this blood vessel ruptures, then the blood is not getting to the nearby cells, and that can cause your brain to start lose some of its function. So if you have a very bad stroke, you can lose the movement on one side of your body, you can not be able to speak, you can, all kinds of things. And sometimes strokes can be recovered from quite easily, and other times they can't. So it's a very dangerous thing. It can also happen in your lungs. When it happens in your lungs, it's called an embolism. So we kind of have different words for it depending on where it happens, but it's the same idea. It's a blocked artery that's swelling up and breaking, and again, because of the pressure. So the other thing blood pressure can do is if your blood pressure gets too high, right, you've got these capillaries. Well, these capillaries are also very small blood vessels. So if the pressure over here is too high, then it begins to put a lot of pressure on these capillaries, and they might either cease to function well or start to rupture and break. And that means that that affects whatever those capillaries are doing. If those capillaries are in your kidneys might stop functioning. So high blood pressure sometimes results in poor kidney function. One of the places they can find high blood pressure is by looking at your eyes, because in your retina you have lots of very small blood vessels. And if the pressure gets high, they'll start to break. And they can see them by looking into your eyes with lenses. And they can see these broken blood vessels as an early sign of blood pressure issues as well. So blood pressure affects all kinds of things in your body, and that's why it's so important to maintain it at a healthy level. And of course, at your age is the time to start developing the good habits that you'll take with you through your life. It's not too late when you're my age, or you're 50 years old, and the doctor says, hey, you got some issues. Exercise and diet still help. But if you start when you're your age and develop good habits, you may not even have the issues at all, right? So the old saying, get off your butt, do some exercise, and eat a balanced diet. All right, that's blood pressure. Any questions?